Och nästa talare är Synnergren från Mobilaris. Och du ska också prata om ett gott exempel på applicerad AI. Välkommen!
Tackar. Hej allihopa. I will take this in English also then. My name is Synnergren. I'm going to tell you a little story about how we think traffic awareness is used to streamline mining operations and how we needed to apply machine learning to actually get it to work. So let's start with the problem then. This is basically the problem. Now it's too late. I mean, as you understand, the mine is a vast tunnel system with very narrow and dark tunnels. And basically the mine operation is, the development of the mine and then the production of the ore, and then in the end the transport of the ore. So vehicles are running through these tunnels all the time. But of course other vehicles, there are service trucks and so on going in these tunnels. But you don't want to do the tunnels more wider than you can get the ore transported out to the surface. So you have an issue with traffic congestion, basically. I mean, in this case, if a big truck is coming with ore upwards and you're coming with a service truck downwards, you need to hit the reverse and going backwards. And basically, we bend the fenders in that. So there are costs involved to this. So traffic awareness is one thing that was needed to make everyone driving vehicles in the mines to understand, will they have a meeting in this tunnel segment? To do that, you need positioning. So there are various methods of doing positioning, of course, and about 100 out of the 1,800 underground mines existing in the world today have pretty good Wi-Fi coverage, I would say. And you can use infrastructure like Wi-Fi to do positioning, and you basically get, as you see up here then, this very chunky type of positioning. Every time you switch to a new AP, you will see that the position go with updates. But you really need to have this more smooth positioning. So we said, let's try to figure out a way to do this without massive investments in infrastructure. So the basic idea is very simple. Take the speedometer of the truck, take a clock, take a gyroscope, and you multiply the time with the speed, and you get the distance, and you look at the angular velocity from the gyroscope, and you can see how you turn. And you basically get some sort of snail trail of your movement, and you pattern match that to a map of the mine, and you can basically see where you are. The issue is that there is a lot of errors in this. I mean, the gyroscope is a cheap consumer electronics type of gyroscope, so it has drifts. The map is not perfect. The speedometer has really no coordinate system, so if you drive north or west or south, it's just absolute speed. If you put in the reverse, it's just absolute speed. So all of this gives us the challenge that we needed to solve them. And basically what we ended up doing were an algorithm where we did self-calibration of the system. So as we go with our measuring device, we try to figure out what is now the current error in our gyroscope and compensate for that. So that was the first level of self-learning we had to do. Then if you put in the reverse, and the speedometer still gave you a positive speed, we needed to figure out when do you put into reverse. So we need to find some special patterns there so we could use that. We ended up having a handful of different algorithms that we jump between to get this very accurate. And then we had a lot of thresholds that we needed to use to move between these algorithms. And now we started to put this into trucks in production. We got a lot of data. Now we figure out when is best to use which of these algorithms. So we got this data into it, and we try to learn from this data on what thresholds in the algorithms to set. And here we have unsupervised learning. We have no idea how they actually have moved in the mine, the data we get. We just get the data we have there. But we know that a truck cannot drive into the wall and continue. It cannot just by magic appear 300 meters later in a millisecond, and these kind of patterns. So we can search for these patterns and we can train the algorithm to set optimal parameters. So we worked with that and got this working pretty good. Then we needed to do traffic awareness, and basically now we're talking about doing your usual GPS type of navigation device here. The issue we had here is that we have just a few tracks that have this rather accurate method, and we have a lot of other tracks with this jumpy 50, 100 meter accuracy Wi-Fi. So in this mixed scenario, you can only say that there is a certain probability that you meet the truck when you go into the tunnel, because they cannot turn around the corner, but the chunky Wi-Fi position has not detected it yet. So here we work with that, and here we also to figure out the usual patterns, how trucks are moving, and use that into the decision to get a good precision in our when we estimate whether you have a coming meeting in the tunnel when you enter it. So this is the way we have worked with it, and now we are getting a lot of data from our trucks out there. And the future is a little bit unclear, but we believe that we can do a lot of interesting things with machine learning and AI on this data, and further improve the operations. But we are not fully just there yet to understand exactly what we're going to use the data for, but we are working with it. So this was our little story about how we now are applying in machine learning in one of our products that are rolling out as we speak. And this was also part of the SIMS project, which the robotics guy from Luleå University here talked about also. So, thank you.
Finns det några frågor till Per? Nej, men då... Ja, titta, Marcus.
I have a very practical question. I mean, here many people from companies. How did you find the right contact at the university to start the work and the research?
This one, that's a very good question. So maybe we'll put it to Ulf if he remembers. I'm a little bit too new to actually. Yes, that's true. Now you say it started actually as a thesis work a couple of years ago. That is correct. Co-op.
So if I may add, exactly this is why we want to build the innovation hub and the excellent center on AI. So all of this information will be visible, transparent. We'll share successful use cases, scenarios, manuals, procedures, all this. So there will not be communication on an ad hoc communication, but will be formalized and simplified. Okay, that is one of the aims why we are here today. That we are trying to solve this type of bottlenecks. Okay, so that was.
Ja, tack. Per.
Tackar.
Vi